All right, today we're talking about something pretty wild from Google research. It's about how a super simple trick, something you and I learned back in grade school, can basically unlock complex reasoning in these giant AI models. So let's dive in and see how they did it. Okay, so you gotta wonder, right? We have these AI models with billions, literally billions of parameters. They can write poetry, they can write code, but then you throw a simple grade school math problem at them and they completely fall apart. What is going on there? It's this weird gap in how they, well, reason. To really get what's happening, you have to look at the two ways you can prompt an AI. First, there's the standard way. You just ask, hey, what's the answer? Simple, direct. But then there's this new idea, chain of thought prompting. And it's exactly what your math teacher told you to do. Show your work. And believe it or not, that tiny little change, it changes everything. So first, let's really dig into the problem the researchers were facing. What happens when you just ask an AI for the final answer? Well, it tries to take this huge leap, a single guess, almost like it's trying to use intuition. Okay, let's look at a concrete example. Super simple word problem. A cafeteria has some apples, they use some, they buy some more. You've got a couple of steps here, right? A little subtraction, then a little addition. Not rocket science, but you do have to do it in order. So you give this to a big, powerful AI model using that standard, just give me the answer method, and it spits out 27. I mean, that's not even close. It's just completely wrong. We have no idea how it got there because the logic is hidden. It just failed. And right there, that's the heart of the problem. The model isn't thinking in steps. It's trying to get the answer in one big jump. And for anything with more than one step, that strategy just completely breaks down. It's like trying to build a Lego set by just staring at the box and hoping the final model appears. You gotta follow the instructions piece by piece. So how do you fix a problem like that? Well, the researchers had this incredibly elegant idea. They went back to basics, back to how every single one of us learned to solve problems in school. It's called chain of thought prompting, and the idea is brilliant in its simplicity. Instead of just showing the AI a question and then the final answer, they gave it examples where someone had actually written out all the steps. You know, the logic, the chain of thought that gets you from the problem to the solution. And what's so cool about this is that it's not some crazy new algorithm or complex code. It's just a fundamentally human way of solving problems. The paper says it perfectly. We naturally decompose problems. We break them down into smaller chunks. All they did was teach the AI to do the exact same thing. Now, let's go back to that apple problem. Look what happens now. By asking it to think step by step, it nails it. First, okay, 23 apples minus the 20 they used, that's 3. Then they bought 6 more, so 3 plus 6 is 9. The answer is 9. Bam! It's logical, it's right, and, this is huge, we can actually see how it got there. We can follow its thinking. Okay, that's one example. That's cool. But does this actually work in a bigger way? Does it scale? Well, the researchers put it to the test on this big benchmark of math problems, and the results were, frankly, stunning. Get a load of this. Using the old just the answer method, this massive model, Palm, it only got about 18% of the problems right. 18%. But with chain of thought, its score shot up to 57%. I mean, it didn't just get better, it skyrocketed. That was a new record at the time. It even beat other models that were specially trained just for math. So we're talking about a 39 percentage point increase. That is a massive leap. This wasn't just some tiny improvement. This was a total game changer, all from just changing the way they asked the question. But here's where it gets really weird and fascinating. This trick, it only works on the huge AI models. If you try this on smaller ones, it doesn't work. In fact, it can actually make them do worse. It's like this ability to reason step by step is an emergent property. It just kind of appears once the model gets big enough, somewhere around the 100 billion parameter mark. And don't think this is just some cute math trick. Nope. The researchers found this show your work method boosts performance across the board. We're talking common sense reasoning, basic questions about the world, and even really abstract symbolic stuff. It works for all of it. So you gotta ask, why is this so powerful? I mean, it seems too simple, right? But it's way more than just a clever trick. Let's break down why it actually works so well. Well, for one, it forces the AI to break a big, complex problem down into little, manageable steps, just like we do. And because it's showing its work, we suddenly get this amazing window into its thinking process. We can see where it went wrong, which makes it way easier to debug. On top of all that, it works on tons of different problems, and this is the best part, you don't have to retrain the whole model. You just have to ask the question in a smarter way. Okay, stepping back for a second, this discovery is a really big deal for the future of AI. It kind of changes how we think about finding new abilities in these models. This one quote from the paper just nails it. Chain of thought reasoning is an emergent property of model scale. What that means is the ability to reason doesn't just get a little better as models get bigger. Instead, it seems to just switch on once a model hits a certain size. And that makes you wonder, right? As these models get even bigger, what other hidden powers might just suddenly pop into existence? And that's the really exciting takeaway here. Maybe the future of AI isn't always about building completely new architectures from the ground up. Maybe a huge part of the puzzle is just figuring out better ways to talk to the incredibly powerful models we already have. It's about learning to ask the right questions to unlock the amazing abilities that are already hiding inside. So that leaves us with one last big question to chew on. If a simple human idea, show your work, can unlock this much potential, what else is out there? What other basic principles of how we think and learn haven't we tried yet? What other incredible abilities are just sitting there inside these models, waiting for us to ask the right question?